So it's going to be a truly fascinating video this time of me talking through some exam problems. What I'll do is when they're fairly straightforward, I'll just talk through them. When they're a bit trickier, like for example, question 3 is a pretty tough one here. What I'll do is I'll put some hints up so you get a chance to then pause it before coming back and checking the rest of the question. So we've got two functions and we've been asked to find this compound function. The easiest way to do this is we're just going to substitute 4 into function f to start off with. And then we're going to substitute that output into function g. And it says to give our answer as a fraction, so it's just 1 over 46. We could have gone and found a compound function in terms of x and used that, but there's really not a need with questions like this. So again, we've got two functions. First one is we need to evaluate f for x being equal to -5. And when we square a negative, we get a positive. And we can put our answer in just like that, just as a fraction. We're then asked to evaluate this compound function for 1. So the easiest way, we'll substitute 1 into function g. And then we'll substitute that answer into function f. We can just leave the answer as 2 over 16. We could simplify it to 1/8, but if we're not asked to simplify it, that extra bit doesn't make any difference. Now, question 3 is trickier. So I'll give you a couple of hints. I suggest you then pause it and try it if you haven't worked your way through the question already. So for part A, we need to show the inverse function of f for 50 is equal to 3. First thing we need to do for this is find the inverse function. Remember our steps for doing that. We change f of x equals to y equals. We rearrange to make x the subject. We rewrite it, so using our inverse function notation. And then we can check that the answer works. So pause it and have a try with this. So we're going to start off with our function saying we've got y equals 2x cubed take away 4. We want to rearrange this to make x the subject. So we'll start off by adding 4 to both sides. Let me just get this out of the way. We then need to divide both sides by 2. And then to get x, we need to find the cube root of both sides. I need to be careful and show that all of this we're finding the cube root of, so I'll do that with brackets. So we've found the inverse function. We now need to show that when 50 is the input on this, the output's 3. So we've got the cube root of 50 plus 4 divided by 2. So that's the cube root. We've got 54 divided by 2, so the cube root of 27, which works out nicely as 3. We've shown this. In this next part, we are given two different functions, g and h, and we're asked to find the values of x for which this holds true. Now, this is just like the second task on the compound function problem solving video, so it might be worth having a look at that. I'll give you some hints. You can pause it, have a go if you haven't managed to try it yet. The first thing you're going to do is to find h of g of x. I don't just mean look at it and go, there it is. I mean to use our two functions here to work it out. We're then going to form an equation because it's going to be equal to this. You then need to solve this to find x, and it is pretty tricky. You do get quadratic that you need to factorize, and it's one where you need to split the middle term. So if you haven't tried it already, pause the video, have a go with these steps. So finding h of g of x, so we're going to substitute g of x in for x here. So we're going to have x plus 2 squared, and I'm going to expand that. Remember, you've got different ways. You've got FOIL, you've got the multiplication grids, you can use the smiley face method. Whatever way you do it, you'll end up with x squared plus 4x plus 4. So now we're told that it's equal to this value here. So we can make our equation. This is equal to x squared plus 4x plus 4. So we've formed our equation. Now we need to go on to solve it. To do that, we need to make it equal to 0. So if we take away x squared from both sides, take away 4x from both sides, take away 4 from both sides, we'll end up with it equal to 0. So that will be 2x squared, take away 3x, take away 5 is equal to 0. So on this quadratic, because the coefficient of x squared is greater than 1, it's one of those where we need to split the middle term. We're looking for a pair of numbers which are going to add to -3 and going to multiply to 2 times -5, so multiply to -10. -5 and 2 work for these. So remember how this works. We keep the 2x squared term as it is, but we're going to split this take away 3x into take away 5x plus 2x, and we've still got this take away 5 on the end. We factorize these first two terms, so we'll just get x, 2x take away 5. We factorize these second two terms, and we should get the same thing in the bracket here, which we do. And we need a constant outside here, so we'll just put plus 1 times 2x minus 5. Then last step, we're going to have x plus 1, and then 2x take away 5 is equal to 0. And we're almost there. We factorize it. We now just need to see which values of x will make this equal to 0. So thinking about making the first bracket equal to 0, well, if we've got, sorry, the pen's not playing ball. So if we have x is equal to -1, that will make the first bracket equal to 0. So 0 times anything is equal to 0. Or we can make the second bracket equal to 0. So for that, we'd need 2x to equal 5, which means that x would have to equal 2.5. So there are two solutions for this. X is equal to -1 or x is equal to 2.5. So you should have had a try with these questions already. I'll talk you through them now. So f of g of 2. For this, we don't need to find the compound function in terms of x. The easiest way is to just substitute 2 into our function g, and then substitute that output into our function f. Now, we're told for the second part that h of x is equal to f of g of x. And we need to find an expression for the inverse function of h. So first of all, we're going to find out f of g of x. Now, we could expand the brackets here, but it's going to get a bit messy. We'll keep it like this and see if we can get to the answer through this way. So we need to find the inverse function of this, because this is equal to h of x. Remember how we do this. We're going to say that y is equal to our expression here. We're then going to rearrange to get it in terms of x. So the first thing we need to do is cube root both sides. We need to add 1 to both sides. Just bring it up over this side. We then need to divide both sides by 4. We then just need to use the correct notation to write this out, and they've got the inverse function of h written here for us. So let's write it nice and clearly. And that's our answer done. So, question 5. Again, we've got 2 functions here, and it's asking us to show that g of f of x is equal to this. So what we need to do for exam questions like this is show all our steps of working really, really nice and clearly. So let's start off with g of f of x. So we're going to be substituting this into here. And you can see at this stage it doesn't look the same as this, so we're going to have to work through the steps we've got. So let's keep the 2 outside the brackets here. We'll expand these brackets here. Remember, FOIL, grid method, smiley face. And then let's tidy up what's in the brackets there, because we've got +1, take away 1. Keeping an eye on this that we're trying to show it's the same as, we can see we're just a step away now. If we factorize x out of these brackets as well, then we've got to where we need to go. And we've shown clearly through the steps how we've got the original g of f of x, and then how we've worked through the steps to get there. We now need to find the inverse function of g, and then substitute 7 in it. So we'll start by saying y is equal to 2 open brackets, x take away 1 close brackets. And we need to rearrange it to make x the subject. I'll just write it out a bit more clearly this side. And then we need to substitute 7 into that. Oh, tell you what, when I write that out, I should use the correct notation here. And then when I substitute 7 into that, I've got 7 over 2, so 3.5 plus 1, so we've got 4.5. We could write that in different ways. We could write it as a decimal. We could write it as a fraction with 9 over 2. Any way is fine. Question 6. First of all, starting off, we just need to evaluate the function f for 10. And that's all we need to do there. We then need to find the inverse function for g. So following our steps again, y equals, rearrange to make x the subject, and then rewrite using correct notation. They've got the start of that for us here. Last part, we need to show that f of x is equal to 9x, take away 48. So similar to question 5, we need to make sure those steps are nice and clear. So in place of x here, we're substituting 3 open brackets, x minus 4 close brackets. We could have expanded that before we put it in. Still got that minus 4 at the end. But either way, we need to show our steps nice and clearly. I should have actually shown an extra step in there before I did that. Just to make sure it's totally clear. And then I can expand it out. And yep, I've shown it's equal to this. Okay, hopefully you found these couple of questions fairly straightforward. Starting off just by evaluating this with -4. Which gives us 18. We had another show that question, so we've just got to really make it nice and clear again. So we know using our functions at the top, if we substitute this into here, and we're going to need to expand the brackets here. So that should be a +9 because it's -3 times -3. And there we have shown that it's equal to this. The last part here is really similar to the compound problems we looked at on the other video. So we've seen that g of f of x is equal to this. So we just need to work out what f of g of x is, and then we can use them to set up an equation and solve them. So f of g of x, this time we'll substitute this into here. And we need to solve it, so we're now going to form our equation. So 2x squared plus 1, we want to find out when that is equal to this. And if you want to pause it and just practice for this next bit, it does work out quite nicely as a quadratic. You don't have to split the middle term because you can divide both sides, so the coefficient of x squared is just 1. Okay, have a try with that. So if we take away 2x squared from both sides, we're going to take away 1 from both sides. So we're going to end up with 2x squared, take away 12x plus 10 is equal to 0. And hopefully you've seen that if we divide both sides by 2, we'll have x squared, take away 6x, plus 5 is equal to 0. And when we just have the coefficient of this being equal to 1, we don't have to split the middle term. It makes life quite a bit easier. So we're looking for a pair of numbers which will add to -6 and multiply to 5. So if they're multiplying to a positive number but adding to a negative, they both must be negative. And here -5 and -1 are the numbers we're after. So we've got x minus 5 in the first bracket, x minus 1 in the second. Last step to solve it. So what's going to make this bracket equal to 0? Well, that will be x is equal to 5. What will make this bracket equal to 0? That will be x is equal to 1. So we've solved it for the values of x. The way question 8's been written may have seemed a bit confusing at first. So it's asking us to express f of x plus 2 in the form ax squared plus bx. And here a and b are just constants, just numbers. So all we're going to do is we're going to put x plus 2 in place of x here, so where it appears on these. So f x plus 2 will be is equal to 3 times x plus 2 squared. Take away 2 lots of x plus 2, take away 8. Might be worth pausing it here and seeing if you can finish off the question now. So expanding these brackets, tidying it up until you get into this form. So if we expand the double brackets here, we'll get x squared plus 4x plus 4. Take away 2x. Now, because we've got this takeaway here, we've got to be careful when we expand. So we can think of that as negative 2 times x is negative 2x. Then we've got negative 2 times 2 gives us negative 4. Take away 4 and take away 8. I'll expand this first bracket out fully. And then we've got a bit of tidying up to do here. So we've got 3 lots of x squared. We've got plus 12x, take away 2x. So that gives us plus 10x. And then we've got plus 12, take away 12. They cancel each other out. So we've got it written here in the form ax squared plus bx. Overall, I think question 9 is definitely the hardest question here. The first part, we've got to substitute 5 into our function. So that will give us 1 over 7 plus 1 over 2. Remember, adding fractions, we need a common denominator. So if we multiply top and bottom of the first one by 2, top and bottom of the second one by 7, we'll get that common denominator of 14. Adding fractions, when it's a common denominator, that stays the same. We just add the numerators. Now, you may not have been clear what this second part was asking for, so we need a value of x for which f of x is not defined. I'll start by giving you the answers and then explain why. Now, 2 possible answers. The first one is x is equal to negative 2. The second one is x is equal to 3. The reason for these is down to the fractions in the function. If we look at this first one, if x is equal to negative 2, we end up with 1 over negative 2 plus 2, which is equal to 1 divided by 0. And this is not defined. And the reason for that is if we think, let's use this example. So if we had 8 divided by 4 is equal to 2. Using what we know about division and multiplication, if we multiply both sides of this by 4, we have 8 is equal to 2 times 4. So we know both of these are true. In a similar way, if we have 1 divided by 0, and let's say that's equal to the value x, if we multiply both sides by 0, we get 1 is equal to x times 0. Now we know for any value at all, if it's multiplied by 0, it's equal to 0, so this does not hold. And that's what it means by it being not defined. It's in this third part that it gets really tricky. Now, the first bit is saying when the function is equal to 4, find the possible values of x. So let's think about that a bit more before we move on to this tricky next part. So we want when this is equal to 4. So let me write it out here. Now, we want to give our answer in this form here. Hopefully seeing this is making you remember something because the form looks really familiar. And what that thing is the quadratic formula. So there's a hint in the question about what we're going to need to do later on. But let's start off by solving this equation. So what we need to do here is we're going to multiply both sides by x plus 2. and then we're going to multiply both sides by x minus 3. I'll do this step by step just to make it really clear why. So first of all, if we multiply both sides by x plus 2, over on the left we've got 4 open brackets, x plus 2 close brackets. The first fraction here we're left just with 1, and the second fraction we've got x plus 2 on top now, x minus 3 on the base. And now we're going to multiply both sides by this. So I'll expand these brackets out later. I'll put that in brackets just to make it a bit clearer what's going on. And again, I will for that one, which is just the numerator here. So hopefully it's clear how we got to this stage. Now we need to expand these brackets, and then we need to rearrange to make it equal to 0. So we've got our quadratic here is equal to 0, and now we can go on to solve it. Normally I'm looking straight away to see if we can factorise it because that's generally easiest. But remember what it said in the question. It wants our answer in this form, so we want to be using the quadratic formula. Hopefully you can hear the tune of that, the song of that in your head. I won't burst your eardrums by singing it myself. And we need to use our values from our quadratic for A, for B, and for C, and to go through the steps to solve this for X. Remember to be really careful as we go through this. It's really easy to make mistakes, especially regarding the negatives. And so we get this for our solutions of X. It's in the form we're asked for in the question where P and Q and R are all positive integers. So it's absolutely fine to leave it like this. You may have spotted you could simplify it a bit further, and that's because the square root of 404 is equal to the square root of 4 times the square root of 101. So that's equal to 2 root 101. So we could use that, like I say, you don't have to. You might have used that to have simplified it further. To this. The last one's a bit more straightforward, just starting off by finding the inverse function of f. So hopefully you're fairly familiar with these steps so far, making it y equals, rearranging it to get x as the subject, and then writing it with the correct notation. We've already got here the notation for the inverse function of f, so we've just got to remember to change the y back to an x. The second part, we're given the function g, and in here we've got letter k, we're told is a constant, so it's just representing a number. And we've got to work out the value given that f of g of 2 is equal to 12. So first thing I'm going to do here is I'm going to put 2 into the function g, and that will give us k times 2 squared, and so we can write that out as 4k. We can then use this output going into our function f. Oh, yeah, that's 4 times 4k. And then we can tidy that up. So 16k, take away 1. Now, that's what f of g of 2 is equal to. But we're also told that this is equal to 12. So we can set up our formula. And then solve it. And the easiest way with this is just going to be to leave our answer there as a fraction. Job done.